Good morning, everyone. Today we are going to start with the process of slope staking. If you would refer to your slides in on page or slide 22, we will talk a little bit about that. I'm actually going to be using slides 22, 23, 24 to explain this, but I'm going to leave it on slide 22 and be explaining from there. So if you will all move to slide 22. I am going to begin by talking about the concepts of slope staking. First of all, you will notice right here from the slides that we have a few things that we have to draw your attention to. First of all, the dashed line that you see right here represents the existing ground. The solid line that I show here represents the finished proposed profile of the roadway. Now remember, bearing in mind this is a section along the roadway, left and right of the center line. The center line is represented by the CL you see on the drawing there. The first thing we need to do in slope staking is establish the elevation of the original ground. Now, if you'll notice from this section, the proposed grade sets below the existing grade, so therefore this is what we would call a cut section. The objective here is to find the place or the location where the ground and the design grade will intersect so that construction may take place. That would be this point right here and this point right here. This being left of construction, this being right of construction. Now notice right here, the information I'm about to show you is based upon the left side of this. So the first thing we do is we need to establish the elevation of the ground. Now, we're using a traditional level, auto level process here, of which we have set up an auto level and we've established the height of instrument. You'll notice that the height of instrument is 486.28. The next thing I would do is, knowing that my construction project is going to, I would have to know the template of my construction project. I would start by looking at the design information for this particular area of the roadway. And I note that the distance from the center line to the ditch or the lowest point on the roadway is 29 feet. So I know I do have to go at least 29 feet to find that out. Then there's also a 3-to-1 slope in a cut section to decide where it actually would tie into the existing ground. So therefore, we know we have to be at least 29 feet to the left of this, or potentially more. So in this method, or the method of slope staking, it's a trial and error process, as I mentioned in the last video. So therefore, we have to start by finding the location of a point on the ground and then moving right or left based upon that information. So we're going to start out with some known things here. First of all, we know the elevation of the height of instrument is 486.28. From the profile grade, we find the design elevation is to be 480.00. The height of the instrument is 486.28. So therefore, you will also notice that the elevation differential is 3.74 between the center line of the roadway and the bottom of the ditch. So what we are actually looking to do is get this 480 elevation and then subtract the 3.74 so that we could find the elevation of the ditch line at this particular point. Now, as you would move on to the next slide, I am going to leave it on this slide and explain the next slide. On the next slide, you will see that the ditch invert elevation is 480 minus the 374. What this does is this leaves us with a ditch line elevation of 476.26. If we take that and subtract that number from our height of instrument, you'll see the 486.28 minus the 476.26, we get a 10.02. The 10.02 represents our grade rod, or the distance we would want to get if we were at the point where the finished ground and existing ground intersect. Now, I don't expect that to happen in the field because we know we have to cut down to the section. But I am going to start out by saying, in this situation, it looks like we've sent our rod person to the left of construction. And first thing we're going to do is we're going to find the depth of the cut. So therefore, using the equation that's shown in there, the depth of the cut, we're going to find the distance. So here's what we're going to start out is trying to find our distance left or right of that center line. In this situation, we're going to go left, which is represented by the X on the drawing there. You'll see right here. Now, this is the distance we don't know, so we have to try this. So we're going to start out by computing where we are. So what we do is we send our grade rod person out, and it looks like in this example we sent the grade rod person out 35 feet from the center line. So 35 feet left of the center line. The grade rod is represented right there. You can see by the when the person goes out to 35 feet, we shoot an elevation of 6 on the rod. So if we take that 6, subtract it from the 10.02, which is our grade rod, our design grade, we're seeing that we still have to cut 4.02 feet. That 4.02 feet represents the depth of the cut at that location. Now, if I take that 4.02 feet and I multiply it times 3, why would I multiply it times 3? I would multiply it times 3 because the slope is 3 to 1. Remember, for every 1 foot of vertical cut, there's 3 foot of horizontal distance. So therefore, I take the 4.02, multiply it times 3, which gives us 12.06. If I add that to the 29 foot of distance to the center line, or to the ditch from the center line, I end up with a 41.06 distance, and I know that I am currently at 35 feet. So therefore, I would have to begin, I would have to start right there with my first shot, and therefore I realize that I must now move my rod person farther out. So this was our first trial and error process. 35 foot isn't sufficient, so we're going to move our rod person farther to the left or farther than 35 feet.